So here we have another video talking about an oxide of sulfur, that is sulfur dioxide. So friends, just for the sake of curiosity, this is how sulfur crystal looks like, right? We move on to sulfur dioxide. As the name suggests, we know it is an oxide of sulfur, and sulfur simply when reacts with atmospheric oxygen, sulfur dioxide is formed, along with 68% of sulfur trioxide, which is formed as a side product, right? To produce sulfur in the laboratory, we react sulfuric acid, or more specifically dilute sulfuric acid with a sulfite to form sulfur dioxide. Now you know what, when I was talking to a group of students and I said that sulfuric acid when reacted with a sulfite forms sulfur dioxide, and I showed them this reaction, they were like, ma'am, you have pulled out the wrong reaction. But it's not the case. The sulfite ions are coming from sulfite over here, and sulfuric acids provide me hydrogen ions, and as a result of their reaction, sulfur dioxide is what I get. So this is the laboratory method of preparation of sulfur dioxide. Now how is sulfur dioxide prepared industrially, right? When sulfide ores are roasted, right, for their concentration process, sulfur dioxide gets generated as a side product of this roasting process. This sulfur dioxide is then liquefied under pressure and stored in steel cylinders. Let us come to a quick look on the physical properties. Sulfur dioxide is, has a boiling point of 263 Kelvin, and it liquefies at room temperature under a pressure of 2 atmospheres. By the way, do we know what is room pressure? We all know what is room temperature. 1 atmosphere, right? The pressure around us is roughly 1 atmosphere, or 760 millimeter of mercury, or 1013 bars, right? Let us now have a look at a few of the chemical properties of the gas. So sulfur dioxide when reacts with water forms sulfurous acid. Sulfur dioxide when moist acts as a reducing agent. And how is it so? For example, it converts Fe3 positive ions into Fe2 positive ions. It also converts potassium permanganate, acidified potassium permanganate solution into a colorless solution, because the potassium permanganate dissolves into its ions, and hence the purple color of this KMnO4 decolorizes. This acts as a test for the presence of sulfur dioxide gas as well. In presence of charcoal, sulfur dioxide forms sulfuryl chloride.